Hello, everyone. Day 2 at MilAM, and I have sitting here next to me, fresh off of the stage, Mr. Aaron Johns, who's the VP of Digital Solutions at Siemens Government Technologies. Welcome to the podcast.
Thank you very much. Happy to be here.
Yes, well, so I know you talked a little bit with our Executive Director, John Wilczynski, about some digital solutions, and I wonder if you could just talk a little bit about what you do and the relevance in the defense sphere.
Sure. Siemens Government Technologies is responsible for delivering the entire portfolio of Siemens solutions back to the federal government. My particular portfolio involves the entire breadth of the Siemens software solutions and portfolio, as well as industrial and factory automation solutions. So as it relates to the government, we're very much engaged in a lot of modernization activities, especially at some of the depots and repair facilities around the world.
So you really provide a translational layer between the digital sphere and government.
We do, and we try to. We also try to provide a collaborative ecosystem in which the government customer can engage with their suppliers. For example, during an acquisition cycle for a new asset or a weapon system, they can collaborate more effectively, more efficiently. That results in a faster acquisition cycle, a higher quality product because the requirements don't need to be translated. They're understood because it's through constant communication.
Well, I mean, with the sheer turnover that we have as a consequence inside of our military, I'm sure it becomes a challenge to keep everyone up to speed on what the enterprise solution is. And you have older people in command, and then you have younger people who are more digitally literate.
Yeah.
Can you talk about some of the challenges of integrating technologies in this complex organization?
Sure, I think that example you just used, it really drives home the fact of the need for a digital thread.
Yes.
So without that, digital thread lives in perpetuity. So as you design, develop, maintain on that same digital thread, no matter what generation, this generation, the next generation, the generation to follow, is going to have that set of data, those lessons learned. We have aircraft and ships that are in service for 50 to 60 years. So having that rich set of digital data, being able to manage how it changes over time, is even more and more important when you look at it through that lens.
Well, and everything seems to be upending because, well, certainly we have artificial intelligence and agentic agents and things like that. So it's all shifting. I like to say about Additive, since we are at the Military AM conference, that Additive is the gateway drug to digital manufacturing, right? And so if that's true, the complexity that we can achieve is not free when it comes to the digital thread.
Right.
So talk a little bit about what you see some of the opportunities are.
So I think gateway drug might be a good word, but I think it's also it's an impetus. People are realizing that the need to use digital data. We've done traditional manufacturing for years. We know how to do that with paper very well. But this is a chance for us to modernize how we do all of advanced manufacturing, not just additive. Additive may be the Kickstarter behind it, but it can really help improve how we do everything in the maintenance and repair world.
Well, the thing about a digital record is it almost becomes immortal.
Yeah.
And that's a goodness in some ways. So talk about that sense of immortality when it comes to a TDP, or how you guys manage that.
So it's more, so the TDP is almost the end result of a lot of work that's gone in. So behind that TDP are so many different pieces of data that make it up. And really what we focus on is the connectivity of all those different pieces of data. At the end of the day, it's relatively easy to make a technical data package, but it's not easy to manage change. If that design change, how does that ripple across all those different data elements that are required to not just manufacture, but to sustain, to involve a supply chain, understand what materials I need to actually do that manufacturing process, what personnel are needed to do it, and what are the steps to do it. So it's all those different data artifacts and the connectivity between them that I feel is really the value of the digital thread.
You said something a word, connectivity.
Yep.
And while I think we somewhat take for granted connectivity, I think there is a good bit of intention behind it.
Yeah.
And when we're talking about, I don't even know if the word digital thread fully captures it, when we're building ecosystems that need to be operating, and I say interoperability, it means something different in this context.
Yeah.
So I'm looking for a different word, and
Sure.
it's not coming to me. But when you think about the complexity inside of an ecosystem and having to communicate across that complexity, what kind of systems are you seeing? What kind of things are you seeing that can do that?
So the ecosystem is, I look at it in kind of pockets. So the ecosystem could be as micro as a machine inside a facility. It could be at another level, it could be that facility itself. It could be entire depot or base, or it could be a collection of all of a particular military branches. Locations globally.
Yes.
And now to include forward deployed assets as well. So that ecosystem and that communications needs to be secure. It needs to be easily understood by whether you're an engineer or whether you're someone operating in the field. And so really it's that as that ecosystem grows, it's more important that that data is readily accessible and easily accessible, especially in a contested environment. People don't have time to wait on data. They need data immediately, and they need to repair on demand.
Well, in your experience, where does additive manufacturing most often break in the bureaucracy?
I'd say the tipping point in the bureaucracy, unfortunately, is usually involving data rights and intellectual property.
Okay.
And it's not a technical challenge, it's a policy challenge.
Yes.
It's one that I certainly in my role don't influence,
Sure.
but I always
To endure.
I endure, but I always tell people it's not a technical challenge. We can
Right.
protect their intellectual property. We can make sure that ITAR is protected. We can do all those things with technology. It's a matter of breaking down those policy walls between the OEMs and the government.
I know this isn't really fully your wheelhouse, but you're not the first person in the chair to talk about IP as intellectual property as a challenge.
Yep.
And in fact, in the last National Defense Authorization Act, the draft,
Yeah.
not the final version, there was significant language around the right to repair.
Yes.
And I'm using that as a catchphrase, a catch-all for
Yeah.
a policy that is more permissive on behalf of the government
Yep.
to allow digital files and to be utilized,
Yes.
even if you didn't create them
Yep.
in the government side. So it's a challenge. I think congressional intent, there is a whole group of folks in the manufacturing caucus that want to address this.
Yeah.
But I don't know if there's any low-hanging fruit left. I feel like we're running headlong into these very difficult issues. I do think there's a software solution.
Yep.
There's gates and things, right? You would tell me
Yeah.
that you can manage it.
Absolutely. Well, it does need to be resolved. It's not, at the end of the day, what is critical is the mission. And if there's
Yes.
something that breaks that mission and slows that mission down, it needs to
Absolutely.
be addressed, it needs to be resolved. And if it's a right to repair, let's get there.
I agree with that. So I'm going to ask you something else, because one of the things we're all getting hung up on this year at MilAM is contracting.
Yep.
Now, contracting is critical. All of us need to get paid for what we do.
Sure.
And the contracts need to be clear to protect everyone. But are there any contracting mistakes that you see most often in digital thread efforts? Like, buying tools, for example, not paying for, they only pay for half your services. They don't have
Sure.
money for the other half. And the other half tends to be like integration and governance.
Sure.
So talk to me about those mistakes in contracting.
One of the challenges, I think, and one of the things that I feel that we're called upon to fix a lot are past contracting mistakes, where someone contracted a company to build something, not buy a commercial off-the-shelf product, but to build something that does a very small sliver of what the entire life cycle and journey is. And so
Right.
if you look at it that way, that becomes a system integration nightmare. By applying a digital thread, you could look at it a couple ways. You could break down those systems and consume that data. Or a good friend of mine in NavAir used to coined a phrase that I'll use. It's called responsible retirement. Let's just integrate those tools, and at some point somebody's going to realize we don't need them anymore because we can consume that data inside the actual digital thread. So
absolutely.
Yeah.
Well, so you brought up something that I'm keen to pull apart.
Yeah.
Nobody's really talked about this in my world, and that is, as we digitize and as we institutionalize digital manufacturing, you think about the current legal structure for risk and liability.
Yep.
And how our entire tiered system of manufacturing was founded on the base of who can take the risk.
Yep.
Who can stand up if the part fails and a plane falls out of the sky, for example.
Yep.
With the digital thread and digital twinning technology, the things that you're working with, do you see a scenario where that risk and liability framework can change legal precedent because of the ability to truly understand what happened?
So in some ways, yes. So I think with the advancement of simulation tools, I think the ability to simulate full-blown systems and system of systems in ways that have never been done before, by integration of software, electronics, hardware, all those things, and being able to do dynamic simulations of cross-domain simulations, we have a much better understanding of how something's going to perform before we actually build it. Now, does that eliminate physical tests, flight testing? Absolutely not. But what it gets us closer to is making that physical test more of a verification process of the simulation results, as opposed to I got to test from scratch and retest and redesign.
Absolutely.
So
I mean,
that's
the democratization of that data helps out. So I'm going to throw another one at you.
Sure.
We've talked about additive in that it's not just about the printed part.
Yep.
It's everything that happens before and everything that happens afterwards.
Yep.
And what is that? That's design. That's different. The design choices that you make. It's also the post-processing choices that you make. And there's an entire supply chain. It isn't just one company necessarily doing all of that, right?
No.
So, but somehow when we talk about additive, we expect that it's one company doing those things, or the equipment in the same company. That is just not true. There is not the level of vertical integration. There are a few who have done it.
Yep.
GE was the first example of a completely vertically integrated supply chain.
Sure.
And, Stratasys is attempting that, and there's examples. But when I think about the digital thread and I think about the solutions you provide, there's a lot of small companies in the additive supply chain. And they're not linked together digitally. They each have their own lakes. They each have their own, their own CMMC compliance or not, because it's too expensive.
Yep.
So, could you see a scenario where Siemens, or is there a movement for a group like yours to do that on a supply chain basis and help everyone along that supply chain?
Absolutely. So there's over 150,000 suppliers that support the defense and maritime industrial base. So one of the things that we are we're just starting to look at and starting to think about doing is working with some partners to stand up a GovCloud hosted environment with a rich set of engineering tools that really, due to the scale and the number of suppliers that do it, we can lower that cost barrier to them for entry into this, but also get them CMMC compliant at the same time. Without forcing them to do it on their own. We could do it for you, and we could also provide you digital tools that you may never have had the ability to have access to before.
It's simply the height of inefficient that we would be doing this separately.
Yes.
Especially for a business that's under 10 million in revenue, you just don't have the wherewithal to continue.
No.
A regime like that, you need support. So I'm glad to hear that you've thought about it and you guys are working on that. I think it could be transformative and get tier 6 companies, move them up the tiered structure for manufacturing. And
absolutely.
Certainly when we have less providers than ever, those digital solutions that can be enterprise are really important. So
absolutely.
I'm glad you're doing what you're doing, Aaron. So, thank you for joining us today. It's you taught me quite a bit today.
Oh, thanks. It was my pleasure.
Yeah.
So thank you very much for having me.
Enjoy the show, okay?
Thank you. I appreciate it.
Thank you.